A mix of functions for integration are shown in this video. Check how they are integrated here in integral calculus. The first problem requires the antiderivative of the cube of e raised to x plus 2 upon e raised to x dx. We might be thinking of working with exponential integration due to the presence of e, but take a closer look at what we get as derivative is dx all over e raised to x, and also there is an exponent of 3 in the numerator. So this method is not applicable for the function. But if we expand the numerator, we can simplify the functions. So for the cube of e raised to x plus 2, we get the coefficients 1, 3, 3, and 1 from Pascal's triangle, making the numerator the cube of e raised to x plus 3 of e raised to x times 2, then add 3 of e raised to x times 2 squared, and then 2 cubed, which can be reduced into e raised to 3x plus 6 of e raised to 2x, then add 12 e raised to x plus 8. This expanded format is the one plugged into the integral. Then again, distribute the integrand so we get 4 terms, with the integral of e raised to 3x over e raised to x dx, plus 6 times the integral of e raised to 2x over e raised to x dx. Then again add 12 with the integral of e raised to x over e raised to x dx. Then lastly, add 8 times the integral of dx over e raised to x. Get back to the first term and cancel out e raised to x, resulting to the integral of e raised to 2x dx. The second term has another e raised to x cancelled, making it the integral of e raised to x dx. The same goes to the third term, making it 12 times the integral of dx. The last term will have its denominator placed up, so it becomes 8 times the integral of e raised to negative x dx. Before integrating, let's write down the u's and du's. So from the first term, u is 2x, and its derivative is 2 dx, which requires us to multiply dx with 2, then balance it with 1/2. The second term has u of x and du of dx, and nothing should be altered. The third term is taken as is for the moment, and the fourth term has u of negative x with its du as negative dx. So the derivative would have to be multiplied by -1, which will be balanced out with another -1 out of the integrand. So using the exponential integration, we get half of e raised to 2x plus 6 of e raised to x plus 12x minus 8 times e raised to negative x plus c. To take out the negative exponent, the antiderivative can be written as half of e raised to 2x plus 6 e raised to x plus 12x minus 8 over e raised to x plus c. The second example is a combination of two kinds of functions, w raised to 4 upon w raised to 5 plus 16 plus cosecant squared of w all over 1 plus cotangent of w times dw. First is to separate the terms to make them simpler, and then analyze each of them. From the first term, u is taken as w raised to 5 plus 16, and its du is computed as 5w raised to 4 dw. Note that this is somewhat similar to the numerator, only with the absence of the constant 5. Thus, this term can be solved using logarithmic integration. So multiply the derivative by 5 and balance that out by multiplying the whole integral by 1/5. For the second term, u is 1 plus cotangent w, where its derivative turns out as negative cosecant squared of w dw. Insert negative 1 into dw and another negative 1 right before the integrand. So this term could be integrated using the logarithmic method. Then, the integral of the whole function is a fifth of ln of the quantity w raised to 5 plus 16 minus ln of 1 plus cotangent w, and then add c. Example 3 requires the integral of z squared dz over the cube of 1 plus z cubed. As our basic procedure, leave the denominator by taking its reciprocal, making the function the integral of 1 plus z cubed raised to negative 3 times z squared dz. This we analyze with u taken as 1 plus z cubed and its derivative being 3z squared dz, and n as negative 3. With a slightly different derivative, multiply dz by 3 and balance it out with 1/3 out of the integrand. Now we can integrate using the general power formula, having a third of 1 plus z cubed raised to negative 3 plus 1 over negative 3 plus 1 plus c. This is simplified as the quantity of 1 plus z cubed raised to negative 2 over negative 2 plus c. Or we can write it into the negative of 1 over 6 times the square of the quantity 1 plus z cubed plus c. The next example includes the integral of 6 plus sine of beta plus cosecant of beta times the quantity of sine of beta plus cosecant of beta times the derivative of beta. Take note from basic identities that sine of u is the reciprocal of cosecant of u. Plug this into the quantity to simplify the last term. Then multiply cosecant beta into the quantity, where we get the integral of 6 plus sine of beta plus cosecant beta over cosecant beta plus cosecant squared of beta times d beta. Cosecant beta over cosecant beta is simplified as 1, and this is added to the first term, making it 7. So the reduced function becomes the integral of 7 plus sine of beta plus cosecant squared of beta times d beta. Next is make 3 simple integration terms where we can readily take the integral of each. So the first term becomes 7 beta, then the integral of sine is negative cosine, making the second term negative cosine beta. The third term can also be readily integrated into negative cotangent of beta. Then add the arbitrary constant c. Simplify the integral into 7 beta minus cosine of beta less cotangent of beta plus c. Example 5 calls for the integration of the cube root of v plus 15 times the fifth root of v cubed times dv. First is to take out the radicals by transforming the terms into rational exponents, and then distribute the integrand. Now, having the integral of v raised to 1/3 dv plus 15 times the integral of v raised to 3/5 dv. Now analyze each term. The first term can have x as v, and its dx is dv. N is 1/3. Similarly, the second term has x of v and dx of dv. Its n is 3/5. So these can be integrated using the simple power formula, where we compute v raised to 1/3 plus 1 over 1/3 plus 1, plus 15 times v raised to 3/5 plus 1 over 3/5 plus 1. Then add c. Simplify it to have v raised to 4/3 over 4/3 plus 15 times v raised to 8/5 over 8/5 plus c. Write your final answer as 3/4 of v raised to 4/3 plus 75/8 of v raised to 8/5 plus c.